Okay, hello everyone. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let's start the lesson 10. This session is related to the water pumping. How to host water, store the water in a tank by a solar panel, a solar system. To sourcing the water pump to the store is the system. The storage system, the water pump is connected to the electrical motor like a DC-DC motor for the solar panel. If you want to drive from a solar system, then solar PP is connected to the DC-DC system to DC motor. After the DC motor is soft, DC motor soft is connected to the water pump, and water pump to the water is by the head. It will goes to the uh, water tank and store the water there. This system mainly a water pump. Okay, this is the need to rotate it. It's a fan of water pump. Is a two head water. This is the water inlet. It will connect it to the pipe. This water head connect to the overhead pipe to store the water. The shaft of this one is connected to the motor. The DC-DC motor. The motor is drive from the PV panel solar system. I think this is the solar system. By this one, a DC-DC converter are used to drive a motor to constant the output voltage to drive the motor. Then go to supply to the motor. So output or input of motor. This is the DC-DC converter. The capacitor is connected between them to constrain the input current. The terminal of input. This is the overall structure of a water pumping. The duty cycle to control the output. Here you can use MPPT also because of the output voltage. Output voltage is directly proportional to the speed of the motor. If you DC motor, if you want this is a DC shunt motor. We know about EB P5N on 60N. Then EB is directly proportional to the N, the speed of the motor. If EB is increased, then speed is also increased, and speed is increased. It means the water pumping is pump the more water to the tank. It means you can apply the MPPT also here to subtract the maximum power from the PV panel. That's why the controller are used VTIT. There is a controller for MPPT. But you can regulate the voltage at the maximum voltage of the DC rating. It is a V. So it will less than or equal to V M rating. This is the restriction for that one. Voltage rating of a DC motor can't be exceed beyond the rating of the motor. The remaining part you can apply. Okay, power of hydropower. Hydropower, all of you know about the hydropower is rho GS. Where rho is the density of water and the Q is the discharge of water, how much liter per second it will discharge, like that. This is gravitational force. Then the 9.8 to 1 meter square per second. The meter per second square, sorry. It's the head, water pump head. Head we actually you can measure from here. Take a middle of this one. This is the suction head. You can say this is the HS, and this is the overhead, discharge head. This is discharge head. from motor to the tank, height of motor to the tank. This length is discharge length, and this is the suction length where you use to collect the water or take the water from a resource, like you can say like a submersible pump. But in submersible pump, you know about the water suction is directly connected to the motor only, and the remaining part, and I think a whole of part is the discharge pump, discharge head only. There is not a suction head in the submersible pump, but other pump like what is the water pump, water pumping like a monoblock and 1 HP water pump like induction motor used in our home also. There is some suction head, and remaining is the pipe is used to throw the water from pump to the overhead tank. It will be the from the pipe. This one, this is the suction used to. This is the suction head. That's why this is the discharge head. Okay, let's start the question. The question number first is given as the 10,000 liters of water is stored in an overhead tank at the height of 10 meter. And what is the energy store of the tank, overhead tank? Talk about the energy. Energy, you know about the mgh, static energy, where m is the mass and g is the gravitational gravity as the water head. Mass of any object, know about the mass of any object is known as the density, because of density, and in terms of the water you can measure as a density into discharge of the volume. Sorry, the discharge volume, how much volume is there. And volume is in meter cube or liter. This is the density, how much the density is there. I think different type of material have a different type of density per volume. This is the water. For the density of water is the 1000 kg per meter square. Sorry, meter cube is per volume density. In 1 meter cube, if you can take 1 meter cube of tank, it has the 1000 of kg of water is there. That's why this is the density. And m, how to calculate m? M is density into volume. The 1000 kg per meter square, per volume is meter square per, and the q is the volume of the quantity, like in meter cube also. That's why this is the m is the in kg. You multiply up this one do in the q, this is the given in the kg. G is the gravity of 9.8 meter per second square, the oscillation, and h is the overhead. All contained meter only, but there is the given in 10,000 of liter water stored in the overhead tank of a height of 10 meter. In place of m, you can take like rho q in gh. There is a 10,000 of liter. If you convert in this one into a meter cube, know about 10,000 liter is equal to 1 of meter cube. It means this is the 10 of meter cube. You can put the all value there here, and you can calculate the overall energy. Rho is 1000 kg per meter cube is the density of water. You can take it as a directly. Q is 10 meter cube. G is 9.8, and the head is given as the 10. Overhead tank is given as height of the 10 meter. This will be 980 kilojoule. So the 980, this one is the 1 kilojoule. This is the way option is given in the question. Simply energy is the mgh, like a static energy, mass and gravity and height. The height there here is the, in the water tank is the head. Height is replaced by the head. Same thing. And the second question is which of the following is in Notch number is a preferred perfect range of turbulent liquid flow. Turbulent or laminar flow, water flow is depending on the Reynolds number. If Reynolds number is more than 2000, less than 2000, it will be a laminar flow of water. In terms of water, the option is given 0 to infinity, 0 to 2000, 2000 to 400,000, and 4000 above to 4000. The Reynolds number in for the water is less than of 2000 for the laminar flow, and greater than the 4000 is a turbulent. Between of them 2000 to 4000, this is the transition period. Transition between the laminar flow to the turbulent flow. But the question is asking about the perfect range. Perfect range means greater than 2000, greater than 4000 for turbulent flow. Greater than 4000, it means you can say this one is be of greater than 4000 and less than of infinity. This will be the 4000 to infinity is option. Now, what is the roughness factor for the steel pipe with the 8-inch diameter? 0.8 inch diameter. If the roughness factor is depending on the material, which material is a pipe is made, like a PVC pipe or cemented pipe or concrete, like that, a steel pipe, there is some toughness ratio. It will depend on the Divided into diameter. D is the diameter, inner diameter of the pipe. Is a toughness constant of material. For different type material have a different toughness factor. Like you take this of the material written here of some material of silent in mm. For the PVC it will be 0. There is no toughness roughness there. But in steel, still have some 0.1 mm. For the smooth concrete has 0.4. So that silent is 0.1 for the steel. So they are asking about for the steel. This will be in mm, zero point 0.1 mm. Silent for steel 0.1 mm. Then what is the meter? Or you can take as a diameter in mm also. Diameter is given as 0.8 inch. In 1 inch 0.8 into this is the 2.54 centimeter, right? In 1 inch this will be in mm. In 1 inch there will be 2.54 centimeter. For the mm 24 5.4. What is the diameter? (20.32 mm). And what is the roughness factor? 0.1 divided by 20.32. So it 0.004921 or approximate of 0.005. I think option number 2 second B. The next question is, it is expected to send the 10,000 liters of water to a 50-meter top of storage system in 20 minutes. The meter of the steel pipe is 1.5 inch. Then what is the Reynolds number for this water flow? Take kinetic viscosity of water 0.6531 into 10 to the power minus 6 meter square per second at 40 degree. 40-degree temperature is given that. For the viscosity is a different for the different temperature. Viscosity mix mainly related to the density of water, like that. So this is the concentration of the water. Depending on the viscosity, it will be different for the different temperature at a different temperature. Then what is the water flow, like a rate of This will Q is given as the 10,000 liter, and the water head is given 15 meter, 50 meter. Time is given 20 minute, and diameter is given as the 1.5 inch. Viscosity is given 0.6531 into 10 to power minus 6 meter square per second. Reynolds number, all you know about Reynolds number is U x divided by of viscosity V, where U is velocity, meter per second, velocity of water, x is the dimension, but here is the diameter of the pipe. V is the viscosity. This will be in meter, this will be a meter square per second. All of his thing is given, I think viscosity is given and diameter is given, but velocity is not given in this question. Then find the velocity first. Velocity is how much, velocity it means the speed of the water to flow in a pipe. Then how find the speed of water? First of all, find the rate of water, how much water is flowing through an area on a pipe. Then the rate of water flow, rate of discharge. First of all, find the rate of discharge. Rate of discharge is given, it means total water divided by a total time. Total water stored divided by taken time. Ten thousand liter in 20 minutes. 10,000 liter in 20 minutes. This means you can say this will be a liter per minute. 10,000 liter per minute. If you calculate this one, then what is the liter per second? With the same thing, if you find this will be Q dot water discharge rate. It will be a 10,000 liter divided 20 into 60. This will be a liter per second. If the same thing we calculate in meter, then 10,000 liter is equal to the 10 meter cube. Also, this will be 10 divided by of 20 into 60. This will be in a meter cube per second discharge of water. This will be at 8.33 into 10 to power minus 3. This will be meter cube per second. Or you can say that 8.33 liter per second of water is discharged from one head, from lower head to upper head. 8.33 liter per second. Then how much is the velocity of the water? There is a total water discharge per second, but this is not a velocity. It will be in meter cube area. This is in meter cube. Even in volume, this is this much of water in a volume is discharged per second. Then what is the speed or the velocity? Sorry, velocity of the water. It will be, if you divide by the area, cross section area, means this is the pipe. This is the whole water flow like that. But total in meter cube. In whole volume, this will be a 8.33 liter per second will be hot water flow. Then what is the speed of water? It will be, if divide by this cross sectional area in a total, in a volume area in meter square. If I divide by this one cross sectional area in the water discharge, then you can find this will be the meter per second. Then first of all find the cross sectional area. Cross sectional area is diameter is given as like 1.5 inch. Then what is the in meter? 1.5 into, this will be 2.54 centimeter. Then 1.5 into divided by 100 in meter, 0.0254 is meter. This will be the diameter in meter. 1.5 into 0.0254, 0.38, 0.0381 meter. The diameter of the pipe. Then what is the area? Area is pi r square, cross sectional area of this one of pipe. In cross sectional area, this one, then we can say this one will be pi by 4 into d square, and pi by 4 into 0.0381 square. What will be this one? 0.0381 square to pi by 4. It will be 1.13395. It means you can say this will be 14 meter square. Then find the velocity u, which water discharge per volume, water discharge per second divided by of a cross sectional area of the pipe. It will water discharge divided by of area, cross sectional area of the pipe. Water discharge is 8.33 into 10 to the power of minus 3. Okay, sorry, this will be 3.44 into 10 to the power minus 3 meter. 1.14 into 10 to the power minus 3. And then 10 to the power minus 3 is cancelled out. This will be 7.3 meter per second. Okay, if you calculate the velocity of water, it will be water discharge divided by of a cross sectional area. Then you can find this will be a 7.3 meter per second. Use here, then calculate the Reynolds number. It will be a u x divided by of viscosity. This will be 7.3 to x is the diameter. This will be 1.5 inch. I have calculated this one. Diameter in meter is 0.0381 and 0.381 meter divided by a viscosity is viscosity also they given in the question 0.6531 into 10 to the power minus 6, 0.6531 0.31 into 10 to power of minus 6. Calculate this one, you can find the Reynolds number. 7.3 into 0.0381 division of 0.6531 into 425 and 861. I can say 425 into 10 to power of 3. So even Reynolds number. Okay. Only Reynolds number is asking this question. The Reynolds number. Okay. Next question is same thing related to that same question. What is the total dynamic head of the system in meter if the friction factor of the flow is 0.0135? Friction factor is given 0.0135 and given as a G value is 9.8 meter per second square. Total head, you know, head is HS, suction head, discharge head and friction head. The suction and discharge both are given in the question like a 50 meter only, and calculator then take us this one as the suction head and overhead and discharge head. This will be 50 meter and calculate the HF. HF is you know about the formula. This will be F total length divided by F diameter into U square velocity square divided by F 2G. This is the length. Length is length of the head. Total length of the head, it including the horizontal pipe also. But here is not a horizontal pipe. This is given only the overhead pipe is 50 meter. Then take a length is 50 meter and diameter also given. You will calculate it. G is given 9.8. Then all of things is there. Calculate the FHF. F is 0.0135. L is 50 divided by D. There is a D 0.0381. U velocity is 7.3 meter per second. This is this one. 0.3 square divided up 2 into 9.8. Now what is the HF? This will be 48.169 meter. And what is the HS plus HD? Both are 50 meter. Then what is the H? Total head HS plus suction discharge plus HF, it will be 50 plus 48.169. This will be 98.169 meter. Okay. The next question: what is the hydraulic power in kilowatt required for the water flow? In the same question, no, hydraulic power is 9.8 into Q dot A into S. This is the discharge rate. Meter cube per second, and this will be the head length, total head. Okay, power energy, you know about the energy is rho. So simply mgh, m is rho into q into gh, where rho is the density, water density, q is the water discharge, total water discharge. But to know about the power, power is d by dt. But here is the density is constant. You can see there carefully. This is the density. It will be constant for the water, and this is the gravity. It will also constant. This is the water head. It will also constant. Only variable is the discharge. How much water will be discharged from one place to another place. Then this will be differentiate with respect to the time. Then this will be q rho into dq by dt into g into h. Dq by dt, you can say this will the rate, this will do this much of water displaced per second, per minute, this will per time, per unit of time. That's why this will be placed by the dq dot into gh. This is the power. This is the hydraulic power. Simply from the energy, this is the static energy, you know about this one. The power is the rho q dot g h. This is the 1000 kg per meter square. Sorry, per meter cube is the density of a water in one volume, 1 meter cube volume. This is the 1000 kg of water is the density. Then what is the pH? Is this will be a 1000 kg per meter square, and this will be the 1000 q dot g h. Here the q is, this will be in a liter per second. How much water of in liter is be discharged from one place to another place. This will be in water in liter. And what is the meter? Multiply of 1000, it will be go in meter, q dot gh. This will be in meter cube per second. This will be a meter per second square. This will be in meter. The what is total power? Q dot will be calculated, I think this here are the same question. Q dot is 8.33 into 10 to power minus of 3. G is 9.8. Total head is 98.5. the previous question. I will calculate this one 98.169. So if you can, this one will be in a meter cube. If you take this one in a liter, that's why this will be a 1000. We calculate in the meter cube, this will be divided by 1000. That's why take it, this one is the 1000 years. I put the value of this one meter discharge is q dot in the meter. That's why this will be a 10 power 3. 10 power 3 minus 3 cancelled out. 9.8 into 98.169 into 8.33. This will be 80139.13.9 watt. In kilowatt, it will be 8.013 in kilowatt. Next, what is the maximum flow rate allowed flowing following the data of the question 4? Same question number 4. What is the maximum flow of rate is allowed if the laminar flow of the water is expected at the storage system? How much meter per second of water will flow in the system? The water flow is really laminar flow, not a turbulent flow. For laminar flow and turbulent flow, there is the part one parameter is decide that the flowing of the water. This will be a Reynolds number. If Reynolds number is less than 2000, this will be a laminar flow. If R is greater than 4000, this will be a turbulent flow. Between them, it will be a transition period from laminar flow to the turbulent flow. But here is given it will be laminar flow as expected in the storage system. Then what is the maximum rate of water will be flow? Maximum rate of per second, meter per second, it will the speed of the velocity of the water. Sorry, velocity of the water. There is no Reynolds number, or it will be velocity of water into x. In terms of pipe, it will be diameter divided by viscosity. This will also given in the question number 4. This will be maximum of 2000 only for the expected laminar flow. Give 2000 only. Then what is the value of u? U is 2000 multiplication of u divided by x. Then u value, this will be viscosity is given 2000 into 0.6531 into 10 to the power of minus 6. Diameter will be meter square per second. Then diameter also will calculated. This will be 0.0381 meter. And say once you can check diameter is 0.03381. Then what will be the velocity? You get 2000 into 0.6531. 0.03428 meter per second. This is a very low speed. If you excited the water from pump, it will be very low speed. At very low speed 0.03421. Then this will be the laminar flow. If you increase the speed of this one, the velocity of this one, then this will be going through the transition period or the turbulent form. Sorry. A 400 volt DC motor is connected to pump water to an overhead storage tank. The hydraulic power required by the system is 5 kilowatt. If the pump and motor system is 60% efficient, then what is the rated armature current of the DC motor? Yeah, they are given this rated armature current only. Then you can simply take this is the motor current, because of the field winding is not there. It will be separately excited or shunt winding. That's why take as the armature current as the motor current only. There is a motor. This shaft is connected to the a pump system. This is the water head. Then there is an storage system. It will supply by the, if you take as the solar, then solar, there is solar, but there is power battery, a DC system. This is some voltage. This will be some current. This voltage is given as a 400 volt. So asking about the current. Efficiency of a whole system, this one to this one, it will be 60% only. And the power will be required here in the whole system to store the power, storage the water in a overhead tank. It will be a 5 kilowatt is given the question. You can say this one is the pH is water head power. Hydraulic power, it will be a 5 kilowatt. And asking about the what is the rated armature current. It means if you calculate the power of this one through the motor, input motor, then we can calculate the current. Then what is the input power? Electrical power. There is the output of power of motor, but is given is the motor plus water pump. Both are both efficiency included, it will be 60% only. That's why P is input power of the motor. It will be 5 kilowatt divided by of 60%. It will be 60 divided by of 100. 0.6. This will be 8.33 kilowatt. Then what is the power? DC power is V into I. And what is the current? P is 8.33. It means 8330 divided by our voltage is 400 volt of DC power voltage given in the question. It is the 20.825 ampere. Question option number first answer is 20 ampere. The same question, if the efficiency of the converter system is 90%, then what is the required power rating of PV? It means a PV system also is there. After that, there is a converter, DC-DC converter. Then output of this one is connected to the motor. And this is a shaft connected to the pump, and this will be deliver the power, the motor. This is given as a PH is a 5 kilowatt. And after the DC motor, include DC motor, that this is power is required 8.33 kilowatt. This is the input power of motor. You can say P in. I written the P in power of the motor. And converter efficiency, this is the total efficiency 60%. Converter efficiency is given as 90%. And what is the input power of this one? Converter. Pin of converter. It will this power divided by of efficiency 8.33 divided by of 90%. This is 0.9. It will be a 9.255 kilowatt. This much power of the solar panel is required for the pumping system. 9.255 kilowatt. Diagram is there. What is this one? A single stage, we have multi stage. This is the inlet is there. So same outlet is coming to there is inlet. Same thing, this one is inlet. It means water is the same inlet, and this is the outlet. One input and one output only. Single input. But there is some stage, like one stage, two stage, and three stage. That's why this is the multiple stage. Multi-stage in single input, single output. Then this is and with the option is the single stage, single admission. Admission is the enter. Single stage, single output. No, this is the multi-stage. 1, 2, 3. But single admission. Multi-stage, single admission. That this is correct. Single stage, multi admission. No, only one admission. Multi-stage, multi admission. No, only multi-stage, but only one admission and one input, one output. That's why this will be the multi-stage but single admission. Go to the next question. Is a 10 liters of water has to be lifted to a height of a 10 meter. The energy needed for this task. Then G gravity is given as the 10 meter per second square. This is meter per second is velocity. But meter per second square, it will be a oscillation. Then gravity is measured in oscillation, not a velocity, not a force. It will be acceleration force. The energy, you know about the energy by hydraulic system is mgh. Same thing, where m is noted as rho q into gs. This is the rho, it is density of water. Q is the total discharge of water, total water. G is gravity. H is a header. If we talk about the liter, this will be 1 kg per liter. This is in liter. Q is also in liter. Then this will be 1 into Q total is 10 liter. G is 10. H is 10. And this will be a 1000 joule. But it is not in the option. That's why this will be a 1 kilojoule. The gravity is 9.8. That's that. Then this will be 980 joules. The gravity is 10. That's why this will be 1 kilojoule of energy required to lift the water from ground to 10 meter of head of 10 liter only. Second, the potential energy of a body of water is increased by 10,000 joules by lifting it to a height of 10 so the height of 100 meter. Then mass of the water body is same thing mgh, you know, the total energy will be a 10,000 joule by lifting the height of 10 meter. 10,000 is equal to m, g is 10, this will be 100 meter. And what is the m? 10 kg. Water has to be lifted to a height of 30 meter from an underground submersible pump at the rate of 10 liter per second. Consider that there are no losses in the system. The power required by the prime mover is the head is total head is given as 30 meter. An underground submersible pipe at the rate of 10 meter per second. Velocity also there. So here 10 liter. Sorry, this will not velocity. This is the water discharge rate. 10 liter per second. No losses means no friction losses anything. Then power required by the power mover. G is 10. Rho q dot gh mean power and energy rho q gh. This will be talking about the water is only 1 kg per liter. That's why this will be 1. And q gh, q dot is 10 liter per second. G is 10 meter per second. H is 30. This is with 3000. Rho is 1 kg per liter, or rho is 1000 kg per meter cube. There are two formula of this one, two unit. Liter kg per liter or kg per meter cube. If this is in a liter, is given in the liter, then apply this will simply 1 kg per liter. And this is the option number B is 3000 watt. The water tank A is on a building of 10 meter above the ground, and another water tank B is on another building at a height of 25 meter above the ground. A motor pump set placed on the ground is supposed to pump water from tank A to tank B. Then the suction head for this system is, suppose this is the ground level, a pump is here, at a ground, a building is here, a tank. This will be a height of 10 meter, and another building is there, a 25 meter of height. The motor pump set at the place of the water. Like that. The pipes same place is grounded. Ground level. They are given as the what is the suction head. Suction is there. Where is the input of the pump? The length, height is the water level to the pump level. This is the suction head. It means this will be this side to this side. This will be a hole of the suction head. And discharge head is from the outlet of the pump to the input of the reservoir, the storage. This is the whole of the discharge head. There is asking about the suction head. This will be suction head. Suction head, this will be same thing is a 10 meter. But discharge head is the there. But total head, if you ask about the total head will be this one. This one only. Because of total this one, height of this one is also already there. That should be push up the water level, the same level at same level. The remaining is pumped by the extracted by the pump. Right. For this question, this will be a 10 meter because of suction is there. So the same question, the total physical head for this system. Total physical head, but total head is same thing. This will only. This will 25, but 10 meter is the water level already. That's why this is the 15 meter only. The total head is the 15 meter only. Here is discharge head minus of suction head. If there is a same layer at the height level, this will be a 15 meter. A ballast load is used along with a standalone induction generator. The induction generator is connected to the solar panel, and after that it will be connected to the load. But generator is used only for the generating the power, electrical power. This is where comes into the hydraulic power, like a hydro power. Now hydropower, you know about, there is a tank storage where power is water is reserved. You can say this will be reserved when the solar is there. Solar is there, then this will be solar pump is there, and solar is drawn drive the water pump, and then water pump is store the water at this level in the height level. So height level, and a pen stock is there, a pipe, you can say, so pipe is there. Then there is some nozzle. This node at this nozzle is there for the pressurize the power water in a point. There is some wheel is there, a turbine, you can say this is the water turbine to develop the water due to the power, electrical power. There is some cup type of what wheel is there. So the fan is there. This is in the turbine. The shaft is connected through the turbine of a generator. There is a generator to rotate the generator, and generator is supply the power, generate the electrical power, voltage and current. There is a nozzle to throw the water, to a plate or to a cup type of a blade of a turbine. Then this turbine will be rotate like that, and this is rotate, and the generator will be generate the voltage. Yeah. In this, there is the water head is this one, height is the same as the water head in this question. Same power, you know, you can apply same formula Q dot GH, and for energy same thing, mgh. M is rho Q G H, or the power development of the water power, electrical power also. But you know about, there is the some unbalanced here in generator. Suppose you connect the load to the generator here, you connect a load, some load, but load is not a constant, it will some varies with respect to the transient condition, like when one switch is on and one load or extra load is there, or one is the load is disconnected from the system, and that condition this is the induction generator. Suppose this is the induction generator. You know about induction generator, speed is the vary through the load, it is not constant to whole load. Because of there is induction generator, it will have some slip between the ns minus ns, ns minus nr. This is the NS. This will in percentage of sleep. Because of the sleep, you know about the frequency also change. Then this is the generating frequency will be changed when sleep is changed because of the load is vary. Load is vary, then it's the load vary. It means the speed of the generator will vary, and the speed of generator will vary. Then the frequency also vary. Then to prevent this one, because of the all electrical load is the only 50 hertz in India. To prevent this one, to fix frequency, to find the fixed frequency, extra load is connected through this one, known as the ballast load. This one, you can say this is load, extra load is connected, ballast load, BL. This is your actual load. There is connected through the switch, not a constant load. There will be a switch. Like when the load is increases, then this switch is open, or this is the controlled. The switch is the controlled by some function. Then the remaining of the power is, this power is be reduced at that time when the load is increased. This power is be reduced. Then the whole current will be constant like that. Then current will be not sudden change. Then generator speed will not change at that time. Then frequency will be maintained. Then when suppose the load is sudden disconnect from the system, some of load is disconnect from the system, at that time this will connected, the load is by last load is connected, and some of the amount of current will be flow there, then it will work like a load. Then at that time the output load will be output current will be maintained at some point. I will be same, and all the condition when load is there, load is varied like a transient condition, then the overall current will be a same. That's why the frequency will be maintained at a 50 hertz only. If there is not connected ballast load on a load to regulate the frequency, then there is changes in frequency because it is depending on the load only. That's why there is some other condition is because of the ballast load there is some losses is there. That's why generator, the induction generator is not connected through the direct to the load. It will be connected a DC-DC converter to convert this energy, the amount of energy in the DC. After that, we will connect it to the inverter. Then inverter is supply or generate the voltage at a level of a 50 hertz. It will be maintained level because of the, if you changes in the load and the speed of the turbine, the generator speed will be vary, the frequency also vary, but there is maintained a DC voltage on the output of the DC-DC converter. And DC converter is the DC converter output is the input of the DC input of the inverter. Then inverter is maintained as the 50 hertz only, and some voltages. Okay, if there is not there, this is a stand-alone system, and there is a large scale. This means this will be highly costly because of the converter is. That's why it will be connected the direct load. If you want to connect a direct load, then you connect a ballast load also parallel to the load to prevent the frequency or to maintain the constant frequency when the load is varies. Then what is the answer? Answer is to start up. No induction generator, no need of starting because of induction motor is three-phase induction motor is auto start. But if you want to, if you talk about the single phase, there is the some capacitor bike in the motor, but in generator you drive from the prime mover only. There is the, this is the prime mover. This is work in prime mover. Then not need of a startup. Starting. Beta flux control. No, there is no controlling of flux because of here. Flux is controlled by the reactive power only. But this is the active power, not a reactive power. Maintaining the constant frequency irrespective to the load. Yes. While maintaining the frequency inversely proportional to the load. No, 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 no. Frequency will be constant. Frequency will never vary. That's why this option is correct. The third one, maintain the constant frequency with respect to load. And by last load, extra load is connected for the output of the induction generator. In standalone only, in the grid system, you can't be connected directly. It will be a DC-DC converter, by DC converter, after that inverter. And after output of the inverter is connected to the grid system. Okay, next question is the capacitor bank is connected to the terminal of the standalone induction generator. Why? Supplying the magnetizing current to induction generator, keep the induction generator frequency constant, improve the transient stability of induction generator, maintain the voltage constant. A. Supply the magnetizing current. Yeah, this is the constant correct answer. Because of you know about the induction generator, suppose in place of induction generator, if you have a synchronous generator, then synchronous generator have some flux in the field winding because of the DC field winding is connected in a field in a rotor. There is the rotor in the field is connected field winding in a rotor in alternator or synchronous generator, and there is some flux is developed by the DC system, a DC supply, which one is connected through the field winding. There is some flux, and after if you rotate the rotor, it means there is a field winding, and field winding is the excited by the DC source. That's why there is some flux, and flux will be move and cut the armature winding, and voltage will be built up there. There is no need of the extra magnetizing characteristic, extra magnetizing power. But in the induction generator, there are none of the thing like that to a DC system and other thing. But there is only a rotor and motor, rotor and field and armature winding. But then how you build up the magnetizing characteristic in the induction generator? Because of the every winding, every magnetizing winding have required of some of the amount of current to self excite. After that, it will work like a magnet. It will provide a path of the magnetic field, like in transformer. You know about that magnetizing current and working current is different in the transformer. Also, magnetizing current, amount of the current will be required to excite the exciting system of the transformer is there also. Same thing is in induction generator also. It will require some of the magnetizing power, magnetizing current, or some of the reactive power. It will be required to excite to the induction generator, to excitation of the induction generator. Then there is no of the another field, no other another supply like in alternator as the DC system, none of the there, none of the here. But then it will be required of the reactive power. It will taken from the capacitor bank. A capacitor bank is connected to the output terminal of the induction generator. When you want to start the induction generator to build up a voltage, then it will be take a current, take a magnetizing current through the capacitor bank, take the reactive power from the capacitor bank. After that, it will be develop the voltage. That's why this will be a requirement of the magnetizing current. You can say this will be magnetizing current here. Then capacitor bank is connected to terminal of the standalone induction generator to supply the magnetizing current. So keeping frequency constant, the ballast is there. Input transient stability will not there. Maintain the voltage constant. It will be depending on the speed of the generator. The capacitor bank is only for the supply the magnetizing current to excite the magnetizing winding of the generator. Next one, in a water pumping system, the water is being pumped from a submersible to an overhead tank situated at a 25 meter above the ground. The motor pump system is located at the ground level. The water is being pumped at the rate of 24.6 liter per second. The pipe inner diameter is 10 centimeter. The pipe is placed in a vertical fashion. If the friction is factor is 0.037, then the head equivalent of the friction losses. Here we are asking about the HF. Sorry, friction head. The total head is suction head plus of discharge head plus friction head. Friction is depending on the friction. Know about the friction. Friction is there. Then L divided by of D. L is the total length of the head. U square of 2G. Sorry. This is the friction factor. Diameter of pipe. Length of pipe. Length and head is different thing. Head is the section head, discharge head, and friction head. But length is it will consider only vertical line, vertical pipe only. We consider in the head, but in length is the whole pipe length, vertical and horizontal both. That's why this will be known as the length of the pipe. This will be gravity. This will be the velocity, velocity of water, meter per second, or you can also say liter per second. Motor is at ground level. Okay. Water pump system. Water is being pumped from a submersible to an overhead tank situated 25 meter above the ground. Tank is 25 meter length. Motor pump system is located at the ground level. The water is being pumped is data within. Then inner pipe diameter is 10 centimeter. The pipe will place in vertical fashion. Simply there is some pipe system. This will be some overhead system. There is some tank. This head is given like 25 meter. Now, for the calculating of the head equivalent friction loss, then simply calculate the total length. Length is 20. Sorry, there is something mistake in the question. Okay, first, okay, if you want to calculate, there is some ground suction level also. There is a 2 meter of the, well, I think this is the in the question is missing. There are 2 meter of a suction head also. The motor and pump is placed at the ground level. And there is a 2 meter of the suction head to take the water from the ground level to below the ground level. There is 2 meter and 25 meter of overhead. Okay, that's why this is the total head. If you calculate the total length of this one is the 25 plus 2 is the total length is the 27 meter. If you not calculate this one the total motor pump head of a suction head, then this will calculate simply a length of a 25 meter only. Sorry. The width is 27 meter. Diameter is there D 10 centimeter. It means 0.1 meter. Then velocity. Calculate the first velocity. Discharge rate is there. Q dot is 24.6 liter per second. Then if you calculate in meter, first calculate in meter because of the meter per second is the velocity we want to find. Then this there is 24.6 into of 10 to power minus of 3 meter cube per second. Area is pi by 4 into d square. Then velocity is q dot a. Q dot is 24.6 into 10 to power of minus 3 meter cube per second. And there is the pi d square, pi by 4. D is 0.1 square. And what is the velocity of water? It is 3.13 meter per second. Then calculate the HF. F is there given the question 0.037 The length is 27 divided by a diameter 0.21. 3.13 square divided by 2 into G. The value is not there, but then simply calculated this will be 10. We calculate we can taken as the 9.8 also. This this will be a 4.9 meter or approximate of 5 meter. If you take this one as 25 only, then there is a not option in the question, not much in the question option. This one HF is the 25 meter. In the previous question, the total dynamic HS plus HD plus HF. HS 2 meter, there is this one, H is 25 meter plus HF is the 5 meter, which will be at 32 meter. In the same question, efficiency of the pump, motor and DC converter are 70%, 80%, 90% respectively. If the system is being powered by a PV source, then what is the output power requirement of the PV panel? Same thing, there is a PV panel. There are some DC converter. After that, this is the motor. Motor is directly connected to the shaft of the water pump. There is some voltage, then current. Is given as the pump efficiency is very 70% and motor efficiency will be 80%. DC converter efficiency will be 90%. Then what is the power of this one? PVP. To asking in the question. To power this one, we first of all calculate the PH, hydraulic power. After that, divide by of 70%, this will be input of this one. After that, divide by of 80%, this will be input of the DC power motor. After that, divide by 90%, this is input of the DC converter power, the same as the output of the PV panel. Then PH, we know rho Q dot GH, where all thing is in a liter, then this will be 1 into Q dot into GH, this will be liter per second. Then Q dot is there 24.6 liter per second, G is take 10, H is 32. And what is the total power? Total hydraulic power is 24.6 into 10 into 32. It will be 78 into 72 watt. But this is the only PS. Then what is the power of PB? This is divide by of 70%. This is the input power of motor. This is output power of motor divided by 80%. This is the power of the motor input. Then divide by 90% the overall power. Okay. Then total power this is the pH 7872, dwell area of 70%, 0.7. After that divide by 80%, 0.8. After that divide by 90%, 0.9. Calculate this one. We find the 15619 watt. This will approximately up this one 15.306. You take a 9.8, then you find exactly 3.3 15.306. But for the simple calculation, I will take a directly 9, 10. If you take a 9.8, then you will find the 15.306 kilowatt. Okay, I think this is the last question. Could you V1?